So in this case, ladies and gentlemen, what we want to do is they're asking us to identify if we have an ambiguous case. Do you guys automatically notice that we have an angle and two sides, right? Lowercase are sides, uppercase is an angle. So whenever we have two sides and an angle, we have the ambiguous case. It's 1, 2, or no triangles. Would everybody agree? OK? So to do the law of sines, again, remember, we have to have a ratio. So we have to have a side length over its angle. Well, I have a C and a C, right? So that's what I'm going to want to use. And just remember, for the ambiguous case, I recommend having the angles on top. You could do it with the other ratio, but I would recommend having the angles on top. So you'd say sine of 36 degrees over 16 is equal to the sine of big A over little a, which is 17. Does everybody follow me? Yes? OK. So now I just basically solve for a here. So I just multiply by 17 on both sides. So I could say sine of a is equal to 17 times the sine of 36 all over 16. So you can do that first, or you can do that all in one triangle if you want to, or all in one function. So you just hit second sine, which gives you the sine inverse. And then I'll just do 17 times the sine of 36, close my parentheses, divided by 16, and then close my parentheses one more time. And when you do that, you should get A equals 38.647. So everybody got me on that? So now we know one triangle exists, right? Now what we need to do is determine, does a second triangle exist? So what I explained in last class period is these two angles sine of theta equals 1/2. You would agree with me that both of these angles, the y coordinate is equal to 1/2, right? Do you guys agree with me? And these two angles are, both have a reference angle of 30 degrees. So this angle is 150 degrees, or 180 minus 30 equals 150. So what I'm trying to tell you is, when you plug in, when you try to find the inverse, typically you're going to have your two angles. However, your calculator only gives you the one angle because you remember the inverse was within the first or second quadrant. So that's why your angle is only going to give you 30 degrees. So what we need to do to test our other angle, to find A2, so this would be our case 1. To find if there's another A that it could be, you're just going to do 180 minus, to find A2, 180 minus your angle. So I just do 180 minus my last answer. And I get A2 equals 141.353. Now, is it possible, ladies and gentlemen, for my angle A, it definitely can be this one. Is it possible for it also to be A2? And let's see. How would I know if it's possible to be the A2? So what I would do is, what I like to do whenever I'm doing the ambiguous case, I like to draw the pictures of the triangle. I think what I've already told you guys. So C is 36 degrees. And then we just said A had to be 38 degrees, roughly 0.647. Right? Could we find angle B now? Yes. Now, that's case 1. Let's do case 2. Case 2, A2 is 141.323. And B is 36 degrees. C is 36 degrees. Do I have enough room? Can I still find an angle B here? Yeah, there's enough room, isn't there? Would you guys agree? Yes? So therefore, this problem has two triangles. You would have to do the law of sines for A, and then find the missing sides. And then you have to do the law of sines for A2, and then do law of sines. So basically, you would be doing law of sines for 2 different triangles. So you'd have case 1 and then case 2. And then you guys would have to do it twice. Does everybody see that? Kind of? A little bit? So, yes?
Where did A2 come from?
A2 is basically me taking A1 and subtracting it from 180. To find the second, well, to find the second case, see if that works or not. So basically, all you do is once you find your first angle, subtract it from 180. And let me give you. Yeah, basically, you're finding the reference angle, basically.